Hey everyone, welcome back. So we are going to see the first question in binary search, which is 704. So given an array, integer nums, which is sorted, of course, for the binary search, it should be sorted in ascending order, and an integer target is given. So we are given with the target. We have been given with the nums array. We need to find where exactly the target is located. So the target is right here. And this is the key thing to identify this as a binary search. One is the list is sorted, and the second thing is it must be done in O log n, so log n complexity. And in case if we don't find the number, we just return -1 like in this case. So let's see how to solve this. So we have taken two pointers, low and high, and we add them up. So 0 plus 5, and the mid will be the second element here, the element at the second index. We take the floor value. We can even take the ceil value to make this mid, but I would prefer floor value. It doesn't really matter. So we get our mid right here. So we check, is this the mid? No, it's not. So we check, is 9 the target? Should it be this side or this side? How do we know that? This is the sorted array and we find the mid. The mid element is 3, which means that we are more likely to find it on the right side. We don't find it left side. So what do? We need to update the low value. We can actually discard this part. We update the low value to point to this one. So let's do that. And now this would be our new low. Why? Because we can happily discard this part because right here our mid was present and we did not find the element, which means that the element must be somewhere here. So our list became half and we updated our low. So now we need to check which is the new mid. 3 plus 5, which is 8. If I divide that by 2, I get 4. So I'll update my new mid here. This is the new mid now. I check, is this the midpoint we are checking for? Is this the target? Yes, it is the target. So we return this element. So that's the overview. Let's take a step back and look at how we can write an algorithm for this. So I'll write low is equal to 0 because this low is pointing to the first index. And what is high? High must be 5, meaning we have total number of elements nums.length -1. The high pointer must be nums.length -1. Let's write our mid here. Mid is equal to, I'll write short form, low plus h by 2. And this is a floor value, which we will take in our code. 0 plus 5 by 2, which is right here. The floor value is this one. Mid will be 2. So let's put our mid right here. Let's write a flow chart for this. We are checking, is target. The target can be greater than mid, equal to mid, or less than mid. So we check, is target less than mid, or is our target greater than mid, or is it equal to mid? So there could be only 3 possible cases within the array. If we complete the array and if we don't find the element, we return -1. Okay, so we got the flowchart now. We check, is this target is less than the element, mid element, which is 3 in this case. Is 9 less than 3? No, it's not. Is 9 greater than the mid 3? Yes, it is. So we reach this condition. We update low with mid +1. So this will be the new low now. Since our mid is pointing to 2, our new low will be pointing at 3. On the opposite way, let's take a step back here. If this was the case, and if we were to find this element, if this was the target, then the element would lie here, left side. So we might have updated our high to 1, which is less than mid, 1 less than mid. So let's write out that condition as well. If the target is less than the mid element, then high is equal to mid -1. If we find the element right in the middle, return mid. So let's update the low here and we check what the new mid is. So what is the new mid? We take this formula, low plus high by 2. So low is 3, high is 5, 5 plus 3, 8 by 2, which is 4. So this would be the new mid. Let's update that. So now mid is pointing to 4 and the element is 9. And we reached this condition. We check, is the target 9 is less than mid element? So is 9 less than mid element 9? No, it's not. Is 9 greater than mid element? Is 9 greater than 9? No, it's not. So the final condition is 9 equal to 9. Is the target equal to the mid element? Yes, it is. So we just return mid. So we directly return this. Let's see how to code this up. Let's take low is equal to 0, like we saw right here. High is equal to nums.length minus 1. It's better to take a while loop here because the pointers keep updating low and high every time. So before I take while loop, let's write the body of the loop. First I need to find the mid. So what is mid? Mid will be math.floor low plus high by 2. So this would give me the mid right here the very first time. Low is 0, high is 5. So mid is 2 if I floor that. Once we find the mid, we check these three conditions. Is mid equal to target? Is target less than mid? Or is target greater than mid? So let's do that. We are not checking for the mid index, but we are checking for mid element. So that would be nums of mid. If that is equal to target, then we return the mid index. Else if target greater than mid. So what happens if the target is greater than mid? We reach this condition, low is equal to mid plus 1. Low is equal to mid plus 1. Else, meaning target is less than mid. So in that case, low is equal to mid minus 1. And for this particular block here, it happens only once. So we need to update the mid, correct? So what should happen in this case? We calculated the mid, which got to 2. Then we are checking if nums of mid is equal to target. Is 3 equal to target? No, it's not. So we reach else if is target greater than mid? Yes, it is greater than mid. So low is equal to mid plus 1. So we update low is equal to mid plus 1 like this. And then we don't reach the last condition. Okay, so we are done. But now we need to update the mid, which is this line. So this entire process again should repeat. So that's why we have to have a while loop here. So while some condition, this must happen. So what should be the condition inside the while? Let's say we did not find the element, then this low will further update and high will further update as well to the left. So low will move to the right and high will move to the left. And if that happens, if they both cross each other, it means we did not find the element. So our condition will be if low less than or equal to high. Until then, this must happen. If we don't find an element, we return -1. So this is our code. Let's try executing this on Leetcode. Okay, so now we are back on Leetcode. Let's take let low is equal to 0, let high is equal to nums dot length -1. We'll take a while loop here. Low less than or equal to high. Let mid is equal to, we'll take the floor value, low plus high by 2 if nums of mid is equal to target, or we can take the other way around as well, because we are taking this way for the other conditions. So let's keep it consistent. Nums of mid, then we return the mid index, else if target greater than nums of mid, then we update the low, mid plus 1, else high is equal to mid minus 1, and if we don't find anything, we come out of the array and this return statement will be executed. So let's run this code. Yeah, it's accepted. Let's try submitting it. Yes. So it's 81% faster than other JavaScript submissions. So we are doing good here. Thanks for watching. See you in the next video.